And if you have your homework, we'll go through those questions.
All right.
I know we got to think about that.
Okay.
That's embarrassing. What are you doing? I work 8 p.m. It's not nice. I opened it up and then shut.
How was that day,
Stayed
Ryan?
open.
I don't know.
Aw.
Then I finally pushed it shut last month, but now the hip thing is clicking just hit it.
Open first, or
So I have to open it and open it, try to get people are stuck. Different.
Okay, today, the first thing I want to talk about, we are going to continue this chapter 2 topic today. That's kind of the idea. This is something I entered yesterday, so I know some of you were gone for different reasons. You had different things going on yesterday. But I do want to continue this today. Now, yesterday we did talk about your test. So if you want to see your scores like you're going to, we'll do that at the end of class. And see what you got. You have 1 week from yesterday if you choose to retake it. Okay, so if you're not happy with that score, you get 1 week from yesterday to retake it. And all you do is you just show up in the morning, go over the problems you missed, then make a new test and we set a date for when you retake. That's how it works. You don't need to email me, you don't need to talk to me in the hall, you don't need to talk to me right now. You just show up and we'll get the ball rolling on you retaking it. Okay? Remember, you can retake a test once, every test you want, but you can only retake it once. And that gives you better 2 scores, so it's kind of fail safe. But that means you have to retake an entire new test. Okay? Not the same test. Okay? Alright. So our goal today is to talk about this topic, go a little bit further into it, to talk about the type of homework problems that we could potentially see with this. There's a couple different parts of chapter, this first section, section 2.1. Deductive reasoning is one of them. There's another piece to it. But that's what I want to talk about today. But before we do that, I want to talk about one of your homework problems. I know we had homework today, right? That page 71 was due at some point today. I want to talk about number 26. That was the one with the weird sandwich problem. Okay? So if you have your homework out, take it out. Did anyone turn it in yesterday? Okay. All right. So take that out. I'm gonna get rid of this right now. Come back to this here in a minute. Okay. So again, we're gonna do section 2.1 today, which is reasoning. First goal is let's do a quick review of that homework problem. I want to do problem number 26. This is the one with the sandwich, correct? All right. Maybe with our books. Yeah, very. Something like this. It was like you got a sandwich, like this, and they were trying to go for like a world record, and the sandwich had different layers where it was like super thick sandwich, and this deli department trying to make it, or some college trying to make it for a world record, right? And what they said is like the sandwich here is the bread is 8 inches thick. The actual filling, which I don't know what kind of filling it was, but it was 13.5 inches thick, and then the other piece of bread was 8 inches thick. And then they said up here that the bread was like 6.99 feet in width, 6.99 feet in width. Okay? Is that the problem that you had? Something like that? Or you're just looking at me, so you really Yes, okay. So, all right, and then the question is, on this particular problem, is find surface area of the entire sandwich, and then find the volume of the filling, which is this stuff. Okay? That's the volume of the filling. So that'll be something we do later. Okay, now, what type of shape is this? Let's start with that. It's a triangular prism, right? The top and bottom are triangles. The bottom is the walls are rectangles. So even that back wall over here, this side wall, this front wall, they're just perfect rectangles. But it is a triangular prism. The bases are triangles. The walls, the faces are rectangles. So that's just something you had to do in those first couple problems, right? You had to identify which ones were faces, which ones were parallel, and then the other walls were faces. Okay? Now to find surface area, you're basically finding the surface area of this front wall, the area of that back wall over there, which is this one, so slightly longer, than the area of this wall over here, which is the same as this first one. Right? So those are the faces. Then you're going to add up the triangles as well. Okay, so does everyone understand, like, this is what we're adding together to find surface area? Find all 6 or all 5 walls. There's the front, side, back, top, bottom. Okay? Now, to find the dimensions of this is just something I would do. Like this front plate, this front face. Well, do you notice the labels are different? You have to make them the same. And I believe in the instructions they say they want it in square feet. So what I'm going to need to do first is I'm going to need to add those inches together, these inches here, and then divide it by 12, because I need to change this to feet. That one's in feet. This one's not. So if I add that up, 16 plus 13, what is that? 30 something? 8 plus 8 plus 13.5, 29, 29.5. All right, so this is 29.5 inches. Does that make sense when I add those up? Dividing that by 12 will give me the number of feet. So this is how many feet I have. It's at least 1. It's actually 2. So it's 2.46. Right number down. 2.46. Make sense? Now the reason why it's 2.4, obviously it's 29. 24 inches is 2 feet. So it's definitely over that. So that's the dimension for the rectangle. So that'll be one of these front plates. So this is 2.46 feet. And what is the width of that front plate? 6.9. I mean, 6.99 feet. So to find the surface area of that, you just multiply those two together. Okay? That is the same with the plate that's over here. The side one, you can't see it. It's kind of going to the back. That plate is exactly the same. It's 6.99, and then the height of it is the 2.46. It's the same width. So that's this plate. It'll be the same exact surface area. And 2.46 feet. Okay, so you have to multiply those, find that surface area. The problem is this one. It's different. And that's what made this problem difficult. It's not even the inches idea, most people can do that. It's that back plate, this face over here. It's actually devilishly hard to figure out, unless you can rationalize what you're doing. Okay, the height of it is still the same. It's still the 2.46 because the bread hasn't changed thickness just because you're on the other side. It's that wall. It's this wall right here because that's actually this length right here. Does that make sense? It's that length. It's not 6.9 because it's a diagonal. This is a right triangle on the top. That's a diagonal line. That is longer than 6.9. So to find that, you have to do Pythagorean theorem, and that was why I thought this problem was a little bit challenging. So you have to do Pythagorean theorem to actually figure out this wall so I can put the number right here, that number. So Pythagorean theorem, if you don't know, so if I'm looking at that right triangle, Pythagorean theorem is a squared plus b squared equals c squared. That's Pythagorean theorem. Well, this is 6.99. This is 6.99. And I'm trying to find that c number. So 6.99 squared, a squared, plus b squared equals c squared. That's Pythagorean theorem. That's how you find that distance on a right triangle, that one missing wall. Well, 6.99 squared is 6.99 times 6.99. That's what square root means. 6.99, and you get 48.86. So this is 48.86 plus another 48.86 because they're the same number equals the c squared. I add those together, and I get 48.86 times 2. That's 97.72. Now, how do I solve? How do I get that c by itself? Square root. So I'm going to have to take that power 2 to the other side and do a square root. And that's the number I need to figure out. So I'm going to take the square root of 97.72. So if you have a cell phone, I feel like you're using your cell phone, you just turn your phone sideways and you can see the square root. I think every phone does it, even Android phone does it. So square root b 97.72 close parentheses. It's this wall right here, if you don't know, is 9.889 feet. So that's why that wall is important. It was longer than 6. So this wall is 9.89 feet. So now you can figure out that surface area. You have to multiply those two numbers together. Do you see why I thought that problem was difficult? Bless you. Okay, the triangle's easy. The triangles are all the same, the top and bottom. How do you do triangles? You just take the length and width, 6.99 times 6.99. You multiply them together and you cut it in half, because it's half of the rectangle. So that's how you find that. So 6.9 times 6.9 cut in half. And then same thing over here. This is the exact same surface area. 6.99 times 6.99 cut in half. That's how you work. Okay. So that's surface area that you have to, so when you find these numbers, you have to add them all up. Make sense? That's how you do that problem. Now, the volume on this problem is different because I believe what they ask for is not the volume of the entire sandwich, which I thought when I first read it. If you read the little subtlety on that problem number or letter B, they want the volume of the filling. The filling, like whatever they're putting in the sandwich, the meat or whatever it is. Okay? So that means you're actually only finding the volume of the little filling part, which I'm highlighting right here. That's the filling. So that's this chunk right here. I just like pulled it out of the sandwich and put it over there. It's like a little wedge. Okay? Well, to find volume, you take the area of the base times how tall it is. Well, the area of the base is 6.99 times 6.99 cut it in half. Right? That's area of the triangle. But then the filling itself is the height of that little wedge. And that's the 13.5, but I have to calculate that into feet. So 13.5 divided by 12 is 1. 13.5 divided by 12 is 1.125 feet. That's the height of that filling in there. So to find volume, you take the area of the base, which is the triangle, so 6.9 times 6.99, cut it in half, then take it times how tall it is. which is 1.12 feet. You should get volume. Now remember, your area formulas, when you add these up, your label should be feet squared. Over here, when you do volume of that filling, it's feet cubed. Volume is cubed. And then cubed. Okay, questions, comments, concerns on number 26. I set you up so you can at least find all those numbers. Okay, remember, let's do it at some point today. Today, unless you're going. Okay, questions, comments? Okay, I thought it was just a good practice to look at that from. Okay, today, we're just going to go through a couple notes. We'll be done pretty early. I just want to make sure that we cover stuff. We're out of here at 9:37. So I'll go through maybe 10 minutes worth of notes. That'll be 10 minutes to work on homework if you haven't finished it yet. All right, so we're just going to talk about Chapter 2, just do a quick couple points here on what we discussed yesterday if you were gone. We talked about deductive reasoning and inductive reasoning. The title of the chapter 2 is not this. This is just our topic for today. The title of the chapter is actually called Proof and Reasoning. Like, proofs, if you don't know, is justifying the math you're doing. So if you're doing an algebra problem, you're solving it out, it's actually like, give me the reasons why you're doing the steps. Okay, so it's like, it's comparable like showing all of your work. That's what proofs are. Okay. Deductive reasoning is this process we use to actually get to your final answer. It's a way of breaking down a problem into smaller pieces. Okay, but it's a type of thought process. This is something you can develop. And so what we discussed yesterday was the definition, right? So deductive reasoning is something you can control. We're going to go through the definition. That is different than inductive. These are opposites of each other. Most people have to have both to survive. You do, right? So our goal today is to discuss these definitions one more time, and then I'm going to show you kind of the idea of what the thought process here. Okay? 'Cause some people can do this, some people can't. I want to kind of see where you're at. Okay? So let's talk about deductive first, right? Deductive reasoning is that person who has what I said yesterday was like book smart. Somebody who has really strong memorization. So they can memorize facts, rules, definitions. They can do theorems, properties, formulae, and all the other stuff in between, right? So like on the test, I test for deductive reasoning. In that last test we took, you had to know your vocab words. You had to know your definitions and stuff. That takes deductive reasoning. That's just memorization. It's not short-term memory. It's long-term. The people who are really good at vocab are the people who actually look at it once a day. Don't just like cram the day before the test because you lose it all within the first hour. And that's just something that they've actually proven. So you actually go long term. Look at it 5 minutes every day, and you'll learn better. That's deductive reasoning. Now the person that we talked about yesterday was like this gentleman Kim Peek. I think that was the gentleman that I introed yesterday, correct? Did I talk about him? Oh, okay. So we talked about Daniel. All right. Kim Peek, and this, by the way, this will be a live link on the website tonight. I was going to put it on yesterday, but we had volleyball. So Kim Peek is a savant. Right? If you don't know what a savant is, there's somebody with a superhuman ability, like beyond normal human capacity. Right? Kim Peek is a savant that only has deductive reasoning. He doesn't have inductive like Daniel Hammond, like we talked about yesterday. Right? And I'll get to Daniel here in a minute. But Kim Peek recently passed away. I believe I spelled his name on it. I think it's P-E-E-K. To me, not E-A. I'll have to check this one out before I do. But Kim has one of the craziest memories you've ever seen in a human. Now, the problem is Kim Peek, he's labeled a savant because of his rare ability, but Kim lacks social skills. He can't like care for himself, he can't clothe himself, he can't feed himself. He really suffers from basically the downside of being a savant. He can't control the social cues. So he always has a permanent caretaker until he passes away. But Kim had a rare ability where he can memorize everything that he reads. And it's not like Daniel. Daniel, like when he puts effort into it, Daniel can memorize anything. Especially like what we talked about yesterday, Daniel was that professor from Oxford. he memorized up to 100,000 places of pi, right? And he did it in the first reading. He just looked at a piece of paper, he memorized it as he went down, and he could recall it. And they tested him, he went up to 22,000 places without missing a number in pi. And pi is right up here, right? Pi is this number where it's indeterminate, right? It doesn't end, it doesn't repeat. And he memorized up to 22,000 places, or actually 100,000, but he recalled 22,000 in front of an audience, right? It took him 8 hours to do it. And they checked him as he went, so that he was right. Kim, on the other hand, takes no mental effort. He memorizes everything that he views, that he looks at. Everything. So Kim's rare ability is that he can read a page of a book in less than 7 seconds. So what he does is it looks like he's just looking for pictures. That's what it looks like when you watch him read a book. He just flips a page, flips a page, flips a page, and he's actually reading it. And he's memorizing it as he goes. It's the craziest thing I've ever seen. Like it's insanely fast. And he can recall any item from that book. So they tested him on Dave Letterman and Jay Leno and other shows. So Kim went on and they interviewed him, and Dave just did asked him a simple question because he can answer questions, but he can't like have a normal conversation. He can just answer things like. So Dave asked him like, what was his most recent book that he read? And it was War and Peace. War and Peace is like one of the biggest books you can ever read. It's like 1,200 pages. He goes, okay. You have it memorized? Yes. And so he goes, okay. So he told the audience, he goes, audience, I need a number. So the audience yelled out like 156. So okay, chapter 156. Then somebody else yelled a number. Okay, paragraph 3. It's 5th word. Boom, he just says it out loud. And then what he did is he continued to read off the page without the book in front of him from that point. He just read it out loud. Okay, because he has this ability where he has superhuman memorization. Okay, he also has this thing where he memorizes everything. So he reads newspapers. He memorizes all the news from previous years as well. He can recall any facts from any period. So like one of his funniest little things is people have passed him dates. Okay, you know, like January 7th, 1970. Oh, that was a Monday. It was 62 degrees outside. The Yankees beat the Red Sox that day, 2062, and here's the stats. And he just keeps going because he just read the paper that day. Okay, so it's weird. He can just recall things instantly. There's no gap. There's no like thinking. He just recalls it instantly. It's weird. But he suffers from chemical imbalances in his head, so he can't really function. So this will be a link. I'll kind of show you that video here in a minute. That's a rare ability. Okay, most people will never see it. There's a couple of people in Clear Lake that are actually considered to be savants. They live at Opportunity Village, and they're fully spiritual, right? One person in particular is like Steve Perkle. You know Perkle. He goes to all our football games and basketball, volleyball, right? He suffers from a small form of savantism. He has a certain like social cues that are off, but he's really gifted at memorizing sports stats about every player that he watches and when he reads and sees. He has a rare ability to just recall things. So, and you can tell, like the social cues are not there. You know, he can come across as weird to some people, but it just can't help that. It's just the way he is. Okay, but that's a form of savantism, right? Inductive reasoning, on the other hand, is complete polar opposite. It's somebody who has an ability to adapt to any situation, right? They can look at a problem, notice the patterns through observations, and then make a conclusion off of it, what we call conjecture, right? An actual correct answer to a problem, because they have common sense. Like, you can probably think of that person that is not book smart. They fail every single class, but somehow when they go to like an ITBS test, they go to maps testing, they go to ACTs, they get almost perfect scores. Because they know how to look at problems with common sense and eliminate the answers that don't make any sense to that problem. The label is off. The answers are too big. They don't even do any mental thought. They can just figure out the answer within the first 2 seconds of reading the problem. Okay? That's inductive reasoning. Okay? It's for those people that they can adapt to any situation. So like in this class, like what I can tell you is like people that if I were to teach this problem, like how to solve this problem, right? Somebody with deductive reasoning can see this problem and recall exactly how to solve it. That one problem. That's deductive reasoning. You memorize that problem. Oh, the answer is 20 because you added 8. And if I were to give you a new problem, a deductive reasoning person would not be able to solve it. Like if I gave you a different problem. What if I did this? A deductive reasoning person would not be able to solve that problem because they can't adjust because I use different numbers, I use different operations. Inductive reasoning can. So how many people in here can solve this problem right now? Yeah, because you have inductive reasoning. I have never put this problem on the board for you. I don't think I have. Ever. Okay? But you know how to solve it. Because you know how to apply skills you've learned in previous classes to this problem, or maybe you looked at that and went, oh, okay, I see how you did it, and you applied it. That's doing this. It's like doing observations and then applying it to a new problem. Where you're like, okay, that problem looks like you just did opposites, so you add a date. So over here, I'm going to do the same rule. That's the answer. Right? That's how you do it. I didn't need to show you that. You'd be able to adapt. That takes the inductive. Most normal people have both. You don't realize it, but you do. You have both because you have to adjust. You have to have some memorization to survive, but then you also have to be able to adapt to different situations. You wouldn't be in this classroom unless you could. Okay? Because obviously, somebody that wouldn't have inductive reasoning wouldn't be able to even get here because they couldn't adjust to the traffic, adjust to different time schedules because we have a different schedule today than yesterday, so they wouldn't be able to do it. All right, so that's inductive reasoning. And the person we talked about yesterday was Daniel Tamman. He's a professor from Oxford. Daniel's young. Kim Peek is pretty old. I mean, he passed away, but I think he was in his 50s or 60s. Right? Daniel, on the other hand, is my age, about 30, 34. Okay? And he got his form of savantism from a playground accident. Bumped his head when he was a young kid. And he just realized he had this rare talent for memorization, but also for doing huge super calculations in his head. What I mean by super calculations is that Daniel can take a problem where you can say this number out loud. And you can read off the answer within the first couple seconds. Just rattle it off. And you can just say that number out loud to him, and he'd be able to rattle off the answer to you without having to write it down. He just knows it. And the ability is weird because Daniel doesn't suffer from the same social cues as Kim Peek did. He has a rare savantism, but he actually can discuss what he's experiencing. He has that inductive reasoning part as well, which is a rare thing. Usually savants do not have this. They can't adapt. All they can do is answer questions. But Daniel can express everything because he's what, and I don't like to use this word, but he's a typical adult. Right? He doesn't suffer from like mental challenges like Kim would. So Daniel, what he experiences is when somebody says numbers like this to him, he sees flashes of lights, like blips of lights in his head. And those blips of light for him, he for some reason his mind associates a number with it. Like he just sees flashes of light, so you can see he kind of glazes over for a few seconds. He's like seeing lights in his head, and those lights are telling him the numbers that is the answer. And all he has to do is just, when a blip happens, he just says that number out loud. And he just keeps going, and as he says the numbers, it's the correct answer. It's the weirdest thing. And he doesn't go like back to front, he goes front to back. Like he reads it off like it's 1,200,000. And he has this really weird thing, like he sits there and he like his finger wiggles and stuff because he's got a nervous tick that he does. It's really weird. Okay? But he has this form of savantism. Now what we talked about yesterday is Daniel has also super memorization. You know, he memorized 200,000 places of pi. He's a world record for what no one will ever probably compete with him. Okay? He knows like 9 to 10 different languages. And they challenge him, like I think yesterday I talked about, was like Daniel was challenged to answer questions live on TV in a whole new language in 7 days. 7 days. They gave him 7 days to learn a brand new language. And he went on television talk show, and the language that they challenged was Icelandic language, which has a bunch of slurs and different dialects and stuff. And the interviewer interviewed him 7 days later. He's never seen the language before. They just gave him a couple of books. And 7 days later, after that interview, the interviewer said that he knows the language better than he does. Daniel actually knew the language better than the interviewer that was interviewing him. And the interviewer tried to throw him off by doing different dialects from different like tribes on Iceland and stuff, and Daniel answered them all flawlessly. He knew exactly how to express himself, and he knew exactly how to answer questions and stuff, and it's just a rare ability. He can do that for any language. It actually only took him about 3 days to learn it, because the other 2 days he was traveling. So it was just, I mean, that's a rare ability. He can apply, like somebody with just deductive would never one of the smartest men like other than Stephen Hawking. Because of just his abilities. And that's why he teaches at Oxford. Alright, but that takes inductive reasoning. Right? To give you a rare chance at this. Okay? So I want to see how many people have inductive reasoning here. I want to know the next three numbers in that sequence. This takes only inductive. Because you've never seen me write this on the board before. Now you have nothing to base your judgments on. But I need the next three numbers. Okay? If you think you have the next one, okay? What do you got? 16. You are right. Okay? Stop there. And let some of you wrap your head, because maybe you didn't get a chance to look at it yet. Okay? Say that. Thank you. Thank you. All right. Anyone disagree? Agree? Okay, next from? Okay, questions, comments, concerns on this so far? Okay, now, do you notice the pattern? So, this is a sequence. If you know what the sequence is, it's a list of numbers in a particular order. They don't have to least or greatest. You can be in any order you want, but there is a pattern to find the next one, right? So, what's the pattern? Okay, so now you're starting to see the pattern. It's going just up by whole numbers. So that's why I went from 16 or 11 to 16. You add 5, add 6, add 7, and you just keep going, right? That took only inductive reasoning. I didn't show you how to do that. It took actual legitimate skill, right? Right? Now, that's good. That takes strong inductive reasoning to actually understand it. But most people can look at that thing and go, okay, I understand it. But here's another one. Nope, not 47. Close. We're very close. Right there. Yeah, you're really close. 49. Okay, now. Okay, we'll stop there. What are you noticing? It's by odds, right? By odd numbers, so it's going up by odds. So plus 3, plus 5, plus 7, right? Now, what you're looking at here, 11, all right, that's a pattern, right? It's kind of like the last one. Was it the same exact pattern as the last one? No. So again, it took inductive reasoning. If it was the same pattern as the last one, where you add 1, add 2, add 3, that would have taken deductive reasoning, because you just know, oh, it's the same exact problem as the last one. No, it was a different one, and you still got the right answer. You got to 49, and you can keep going if you went on the same pattern. Okay? Because the sequences roughly had the same style, correct? Roughly the same style. Now what I'm going to do is I'm going to break your mind of that same style. Now your world is rocked. Because now it doesn't work anymore. But there is numbers that fall in this pattern. This is 21. That's quick. Quick deductive. Okay. Or quick inductive reasoning. Anyone know the next number? 34. It is 34. Okay. So you're like, God, how is this? What? It's not working. I don't understand it. Here's how. And you probably noticed it. From here to here, did the number change? Right. From here to here, it looks like it went up 1. From here to here, it went up 1. Here to here, it went up, what, 2? Here to here, it went up 3. Okay, this is, and it didn't go go up by 4 anymore. It went up by, what, 5, right? Here's how I made it. We had these two numbers to make that one. We had these two numbers to make that one. We had these two numbers to make that one. You always have the previous two numbers together to make the next one. Is that how you figured it out? Okay. This sequence is called the Fibonacci sequence. It actually happens in nature. Okay? Sunflower seeds. When you look at a big sunflower, right? If you've never seen a sunflower before, there's somebody on the corner by State Street, right here, on the corner that actually grows sunflowers right inside their house. But sunflower seeds grow in this pattern. And there's little gaps between them. They spiral outwards, right? So they'll go 1, 1, 2, 3, 5, and as they spiral out, they're in just these sets. Because they use the previous seed to make the next seed. And it just grows in that pattern. That's how it works. If you look at a snail shell, okay, so here's my weird snail, and there's that spiral-like thing. The ticks on the actual shell itself will be the Fibonacci sequence, like little marks on the shell, because they use as the shell grows, it uses the previous marks to make the next one. It's probably one of the most famous ones. But again, these pattern states took inductive. Okay, you're free to go. See you later. See you tomorrow.
Laura Woody, Sandy Malstead, and Ashley Lousy, please come to the office.
Theo? Crack your ass up, Senator. What? You guys are better than 2018?
Good morning, Mr. Lord.
Good
So I have a question.
How do you know that?
Lord, what happened
Last
here?
year we watched the in-person
Yeah,
Oh, I'm out of here.
I saw them. I sent Ryan.
There's like 2 sessions left.
I just, it was bad.
And he'll be addicted.
Is there like an app for
He'll be
that?
I was on the worst one year.
Because I'm supposed to play that on road trip.
There's like a lot of and then there's like that thing too, like there's like sports ones, there's like
I
Yeah,
don't
for
think
what?
I can
For what?
Like, I know a few colleges.
My favorite one is name every NFL team. I try to beat my time. That was so easy.
I just type in the mascot of the whole thing.
Yeah, you just type in like
That's all over there.
Ravens. You just have the Ravens. I think.
Your type is hats.
Yeah, some of them are abbreviated.
Hats,
The only
bucks,
one,
and award.
Jags, maybe.
Jags.
No, but there's one that isn't abbreviated that I always try to abbreviate that never works. I don't know, I can't remember.
How do you think?
Like in the moment when I play that one, I always try to abbreviate it.
I always end up
I think it's Bucks.
Yeah, it is.
Bucks.
It's
And then Jags.